again, today, I'm so happy to announce that today, Pyramid will offer you this presentation about the programming and the competition pathway. I've been asked tons of questions by parents, when it's coming for when to start, how to start, and when it's coming to the competition, they sign up, then they find out they're not ready. So I bet, Mr. Yao has a lot of, stories and cases like that. So that's why we kind of, invited our great speaker, Mr. Harrison and Mr. Changzheng here with us. They both fantastic tutors, coaches, or you call them teachers. So they too are kind of, a great example of, I think, so Changzheng, Mr. Changzheng is more like a kind of generation like me, and then Harrison is more like a young professionals from our own, okay? And I think two of them share one thing in common. They both have a passion for teaching. Even though they are professional, software engineer, they both have a passion for the younger generation. They both love to teach, and they both pay so much detail to every student in their account, in their classroom. Sometimes I even feel guilty. Sometimes I feel our students need to pay more attention like the teacher does. So I really appreciate it. As the slides shows already, I don't want to read too much detail to you, but this is one thing I want to share with you. Both of them have really, really big heart for the kids. Both of them really take their initiative to develop their own curriculum. Teaching computer science can be very easy, but can be a very tough one when you teach the little one. So I think both of them develop a very, very good, very positive, a very efficient kind of way to teach our kids. I think, Mr. Harrison's class, I heard so many great things about his class. All the kids love to kind of chasing him about the Python class, Java class. And for Mr. Yao, you probably know him, decade, teaching with us or coaching the community kids. And his class, I just cannot, say thank you enough, especially my little one is in his actual class. The effort he put there, the things he wanted pouring at the kids, I just feel sometimes I think my kid doesn't deserve, his coaching. He's doing miles away. So that's something I would like to, really introduce. You probably notice that actually, we as a pyramid has a long way tradition, in nurturing all the students, in the, computer area, I think the programming part and also the competition part. Okay, so, and hold on. So today's topic is mainly, why bilingual programming and our program teaching philosophy and program pathway. This is a part I want you guys to pay more attention for today's presentation. I think, how do I prepare my son, with the programming learning and for the future, right? For the future career, where how much computer science they need to learn if he doesn't want to do a CS major. And then how much the kid has to prepare to start the competitive programming. I think the programming part, the competitive programming part, I think Mr. Yao will introduce a lot. And then I'm curious to know what, Mr. Harrison and Mr. Changzheng talk about the future AI, because that's something as a mom, I would like to know too. Okay, so yeah, thank you all for coming. And like I shared at the beginning, so everyone who joined today's, lecture, if you want to sign up your kids for the, spring or summer for this year, you get our new year, extra discount of 5%. So thank you for joining again. So Mr. Harrison, feel free to take it over.
Yeah, thank you. You can get my screen shared.
Yes, we can see it.
All right, thanks. So my name's Harrison Lowe. I am am I right now? 20. I'm 20, almost 25. I've nearly a decade of teaching experience. I've been teaching chess, programming, English, And I've been at Pyramid here for 3 years teaching introductory Python and Java. I currently hold a master's and bachelor's of science in computer science from the Illinois Institute of Tech. And professionally, I work at Amazon Web Services. And let me just get this presenter view going. And as a software development engineer, and outside of work, I play chess, I play video games, I do some fun hobbies, but and I am also bilingual. I'm able to speak in Mandarin and English, so feel free to ask me questions in Mandarin if that is your preferred language. That being said, okay, so let's get started with the material here. Big thing here is like, okay, why learn programming, right? Well, programming, and there's a lot of like benefits, but these are, I think, a few of the main ones that I like to talk about is they encourage problem solving, they encourage creativity and innovation. They're a good career opportunity. It's great for automation, critical thinking, and innovation. So, for instance, programming involves breaking out a lot of complex problems into smaller and more manageable parts. This way, it teaches you, okay, let's think about this logically. Let's solve the problem more efficiently. Right? Let's do things so that we can get from point A to point B. And to add on to that, then, well, the creativity and innovation, it allows us to create new software. It allows us to use Amazon, to use Google, right? Your phones are all in programming. And it allows us to have this platform where everybody expresses their creativity. They make their ideas, right, into a product. And then that leads to, hey, well, we can have jobs now, right? The demand for a lot of, skilled programmers is always high, right? Even if you're not doing a programming job, even like accountants, right? They'll still need someone who knows some programming. And so it's also allows you a big range of career opportunities where, like for myself, I do software engineering. So I develop software for AWS, and someone else could be, dealing with artificial intelligence, right? Someone else could be dealing with data science. Someone else could be developing a website. The field is very, very big, and it allows for a lot of opportunity in you or your children's careers. Following that, we have automation. It allows us to, make things simpler, right? Make things easier. And it's kind of like engineering, right? Makes us be able to travel from, our homes to work more efficiently, that we don't have to walk, right? It involves critical thinking, very much like problem solving and innovation. I think I've also talked a bit about that. So, all this are a few reasons why you should learn programming and why we think programming is such a valuable skill. Now, talking about my programming teaching philosophy a little bit, and my programming teaching philosophy, when I was in school, I also didn't really like homework. I also didn't really like busy work. But I know that a lot of times you do need to practice. And so sometimes to the student's detriment, and they're like, oh, homework. But I do give homework, and this is because it's a class where it's a 9-week class with I'm only allotted 1.5 hours a week to teach this, and it's pretty fast paced if we don't have anything to practice with. And so the idea is homework is this practice, just like anything else, right? You need to practice in order for you to get better at it. And so it's kind of why I give homework. At the same time, I also give quizzes, as it's for similar reasons. I think it's a good way for me to understand where the student, right, is currently at. Do they understand the material? However, and this might be very different from like normal school or school when you guys were around. It's I have this philosophy where I don't think they should be not allowed access to the internet, right? The internet is such a valuable resource that they can Google something. Go ahead. And so this teaches them to also, okay, they have a different way to problem solve. They don't just have the one way of, okay, how do I solve the problem the, you know, normal way? But they can be like, okay, well, I'm given this time using all the resources I have. How do I solve the problem? And so my quizzes are open book, open internet, as I like to put it. And that's been a very, very like critical point, I think, for me. And at the same time, it also helps me learn, okay, what does the student need to learn? Like what sort of knowledge base do they need to learn to so they can find the solution rather than give them the solution. So in my class, I don't think grades matter for this. Grades are really just an indicator for me to say, okay, what do you know and what do you need to know? And the most important part is interest is the most important. If you're not interested in programming, then you're just not going to learn it very well, right? If you're not interested in trying to solve the problem, you're never going to solve the problem, right? So this like curiosity, this big philosophy of like, okay, well, you need to have them interested in. That's what I try to do my best to do is to give them something to be interested in. And to use something in Mandarin, 就是兴趣最重要的。我个人觉得是这样子，兴趣最重要。So yeah, interest is the most important to me. And so then that leads us into my first class, which is beginner Python. Beginner Python is this introductory course. It's for students who know nothing about programming or computer science, about anything here. No programming experience is needed. They feel free to come in and just look to learn. And we use the programming language Python. This is my preferred beginner-friendly programming language. It is not the programming language that I currently use at work, but I do explain that the idea with Python is it's very, very friendly to new programmers, and it's a good way for students to kind of start their interaction with a real programming language. And there are alternatives that some programming classes start with. They tend to be more like game-oriented languages, where it's more like commands and more like less like commands and more like a game. But I do think like trying to teach them the beginner building blocks is a very critical skill. And once they pick up Python, a lot of us in the industry know once you learn a language, it's pretty easy to go pick up another one. So that's kind of my idea with Python. And ideas we use problem solving and critical thinking skills to solve the problems in the programming. This is on my syllabus and to apply what students have learned in class to new concepts and ideas. And so then we can apply like what I've talked about before regarding critical thinking skills, problem solving, and all that to the class. Now, beginner Python started around 3 years ago when I was first approached to start a class for beginner Python, and then it was like, okay, well, what next? So what next? Well, then it spawned advanced Python, and this built on beginner Python and looks to start interacting with more things that are not just like basic Python. We talk about libraries, we talk about object-oriented programming. Both are pretty like well-used things in the industry. And just like before, like we still want to problem solve. The whole idea of Python and programming is problem solving and getting through the problem. And so Advanced Python builds on that and tries to introduce new ideas. Advanced object-oriented programming, for instance, is the whole new idea, as this concept is taught in most. I don't want to say most. It's taught in all classes regarding AP Computer Science A, and it's also on the AP Computer Science A exam. And so this, I think, aims to give them a taste of this object-oriented programming and allow them, a much, much easier transition into learning about that when they're taking that, like an AP Computer Science A class. And then that also then leads to, okay, well, we're done with Python for 2 classes, right? What about Java, right? Java is that premier, like, oh, AP Computer Science A uses it. It's used in industry. Java is my personal programming language that I work with in my job. And so, and thus we have this Java class, and the idea is to introduce students to Java, to learn about how Java works. We'll cover concepts for AP Computer Science A. We won't cover all. We're still working out some prerequisites regarding this because it's a more newer class. But again, my recommendation is just to have a little bit of basic programming experience, as Java is not as easy to learn as Python, but this is kind of my overall idea, and it's subject to do some change given some input and given my tendency to go through my class and revamp it every so often. So I think you've heard a little bit about what we've talked about regarding, okay, Java 1, and then there's maybe a Java 2 coming. And so we're working on that. I'm doing some research and trying to figure out some new ideas and new ways to introduce Java. I'm doing some reading on my own as well to try to figure out a great way to teach younger students how to code in Java. So now we've seen all 3, and what are kind of the requirements for this, right? So generally some very, very basic requirements, and it's not a hard requirement by any means. Feel free to just be like, oh, can my student do this? Can my child do this, right? Generally speaking, no programming experience is needed for beginner Python. Beginner, like advanced Python, you'll need to know just some basic syntax, meaning basic like ideas. Everything learned in beginner Python, you probably should understand a little bit, and then you can kind of refine them and work with them in advanced Python. Java 1, the recommendation is some basic Python or some other languages. As long as you know some syntax and of other languages, picking up Java is not going to be very, very difficult. Some recommended prerequisites would be knowing a little bit of algebra or pre-algebra. In general, this is like the reason why we always say algebra or pre-algebra is you want to have some logic and understand logic. So once you understand this logic, then you can start understanding, okay, well, why then this, right, in programming? Why do I first do this, then do that, right? And so that's kind of like the basis. And that's kind of why my recommendation is knowing some advanced, a little bit more advanced math in terms of just knowing algebra. There's some topics here, and we'll start with Python, and then you building on beginner Python, and then looking at Java. We've talked about this in the previous 3 slides. So the typical ages, now they're a rough estimate, so feel free to speak with me, feel free to speak with anyone at Pyramid here regarding these requirements. But the recommended ages that I typically see are grades 4 to 9, give or take. If you think your 3rd grader is able to, understand logic and learn, like, yeah, I'm all for trying to teach them programming if they want to learn. So these are, again, very, very rough. So that's the end of like my segment. But the idea here is for your student, if they want to go for this competition programming, you can start like learning some, basic Python, right? Learning some basic Java, and then you kind of can transition your way into some of my colleagues' classes where they teach about the competition. So before we loop back around, we'll send this off to Mr. Changzhen Rao.
Thank you, Harrison. I'll just use your screen. So when I get there, I'll signal. Yeah, cool. Thank you. So flip please. Today I'm just going to introduce the two contests that I've been coaching in Pyramid Academy. One is ACSL, American Computer Science League. The second one is called USACO, USA Computing Olympic, USACO. So I've been doing this since about 7-8 years ago when Pyramid was just founded. I've been at first I started with the USACO coaching. Then later on, I discovered the Excel is also a very interesting and helpful resource. Then can bridge the level like what Harrison earlier mentioned about the beginner Python and beginner programming class, and then advancing to more competitive topics, and also for the kids who enjoy more I should say puzzle from the coding challenges and problem solving skills exercises. And so then recently I've been focusing mostly on the Excel because I just have limited resources, time allocation. But I will cover the two. So first, I'll talk about the Excel, ACSL, American Computer Science League. And the Excels offer the audience about 5 different divisions. That's how they categorize their the students: elementary, junior, intermediate, senior, classroom. They mostly go by the grade level, except the classroom division. Classroom division is supposedly for students who are lacking access to computer, who can only study the principles with poor resource or access to programming. So it's all the theory or the principles and theories contest. There will be no programming contest. The same thing happened for the elementary. Elementary division has no programming problems. Junior, intermediate, and senior, these 3 divisions, they do have programming problems. I will talk more about that later. So this is how this is how the Excel offer. So typically a student will go by the grade level and choose one division. It is very common. It is a very common practice for students who are advancing faster than the average, that don't really go by that level and challenging higher divisions. I think that's welcome, but don't go down. So that's something less likely. Harrison, please move forward. Yeah, Excels cover have a very concrete curriculum or schedules, and what topics they will challenge, and what are those topics. And they offer an official curriculum, what is called the Excel or ACSL Wiki. There's a link in the earlier slides, which you click that, and that will direct you to the page. Looks like this slide, where on each 4 of the contests that showing what short problem section that will cover. So So pretty much, ACSL has a few contests running annually, and starting from November, it will have an overlapping window for contest 1, and then rolling to the contest 2, 3, 4, which is ending in April the next year. After that, there will be another contest, which is based on the invitations. It's called ACSL Final, and that's an individual test. Contest 1 through contest 4, they are team-based contests, but the team members they don't have a chance to collaborate. So there's no collaborations between team members. So we can go back to the detailed topics later. Harrison, can you move forward? Now, the elementary division is a little bit specifically structured because it only covers 4 topics, 1 for each contest. I guess the primary reason is due to the age limit. They would not, they don't want to overwhelm the contestants with too much content. So each, I would say each topic, they will distribute about like a paper size, about, I think it's 10 to 20-ish page paper. Each will describe the corresponding topic, explain the details, mostly are the computer science principles and concepts. Yeah, please continue. So here's about the contest formats. Like the earlier slides mentioned, there are a few contests each year. So each contest season has 4 team-based contests, starting from November through April of the next year. And after the contest number 4, there's an individual-based ACSL final. And this always happen on the particular Saturday, which is the Memorial Day Saturday. And for the individual performers who score higher than 24 points in totally in their first 4 contests. So the contestants participate the first 4 contests in terms of teams. Again, right, the team member, they don't like help each other. They all participate individually, by the way. So the team, they have like a 2 different format, 3-score team, they choose the top 3 performers scores and add them together. The 5-score team is choosing the top 5 performers scores and add them together as the team scores. And there will be a rank for the teams. But for the final, they only consider individual performance. And please move forward. So there are 2 types of problems. Earlier, the topics, I listed the topics covered by the short problems, which is primarily focused on the computer science principles. The 3 divisions, junior, intermediate, and senior, they have programming problems. This is a different section. And they have different like time limits, different formats. And the finals have a very similar format like the contest 1 and through contest 4. It's just time is you will have more time pressure. So for example, contest 1 through 4, you're going to solve 5 short problems, on the topics of computer science principles in 30 minutes, which is like averagely 6 minutes. You have to solve one problem, and the programming problems will be solved in a window of 72 hours. It doesn't necessarily mean that you're going to continuously code for 72 hours. It's just that you have a longer time frame. In between you can take breaks and drinks, breaks, sleep, whatever. But the contestants must complete the problems independently without any assistance. For the final, they I would say that they double up the stress. 20 short problems in 60 minutes. So averagely, you have to solve 1 problem in 3 minutes. Some of them are I should say they are very challenging. The programming problems, or 2 programming problems, needed to be solved in 2 hours, which averagely 1 hour each. So you can see the increase difficulties. Elementary and classroom, they are the divisions that without programming problems, then in the final, they do not have the, the students do not participate in the programming session pretty much this week there. And right now, the programming problems is one problem. We'll have some description there with certain requirement. There will be input, output, and the students are anticipated to run their problems, run their solutions, solving the problems with 5 test cases. Passing one, each of the 5 test cases will score 1 point, and totally that will be 5 points. So the earlier short problems also 5 problems. So one short problems or 1 test case worth 1 point. So 4 contests, totally 40 points, 10 for each. Individual performance scores more than 24, then will receive an invitation and advance to the final automatically. Yeah, please go ahead. Yeah, so that's the format of the ACSL, American Computer Science League. Now I'm going to introduce a little bit about USACO, USACO. So I think both of these 2 contests, they all have very long history, almost like 4 decades up to this point. The USACO has a focus on offering the opportunities to enhance coding skills and also heavily challenge the knowledge in algorithms and problem-solving abilities. Like ACSL, USACO is also the most recognized programming competitions for high school students. They also have very well-structured contest formats, and it's very easy to register and participate. All the U.S. resident high school students, actually, let me rephrase that. Anyone can sign up, register an account, sign up, and participate the USACO competitions. But only the U.S. residents in high school that will be qualified in the consideration of becoming a delegate to represent the United States in competing in the international one, which is called the International Olympiad of Informatics, IOI. So actually, that's what this organization USACO is supposed to be. They're supposed to be, organize this contest format and select the best U.S. High school programmers and create a team and then participate in these IOI international competitions. Now, with the course of organizing the way how they structure it, they actually created a very good curriculum in nurturing our kids in their problem-solving skills and coding skills, and also the knowledge in the algorithms. Harrison, please. So let's talk a little bit about the USACO structure. There were 4 different divisions. Unlike the ACSL, choose by grade level. The divisions in USACO go by the difficulty level. Everybody starts from bronze and then advancing to silver, gold, platinum, and the next. To begin with, bronze are for students who have no algorithmic experience, but has mastered some basics of a programming language and some basic ideas. I was succeeding that silver, gold, they raise the bar higher and higher. Problems become more and more challenging. As a side note, they are very challenging, very, very challenging. Yeah, please fit, Harrison. So here's the contest format. The track is from the bronze, silver, gold, platinum. After that, USACO organization will select about 20-ish kids, invite them to join a summer camp, which is a 2-week, about 2-week schedule. enhancement, enhance their coding and prepare them for the qualification of the finalists. Then they will select the top four finalists and create a team USA. Then to participate, the IOI happen later. They usually run it in summer or fall each time. The language that for the USACO, they allow C, C++, Pascal, Java. I think they remove Pascal. Probably just still allow, accept it. Java, Python. So all the, I would say that the very classic mainstream programming languages. They also have like a 4 monthly online contest. There's no like a different topics like the ACSL, where this month's topics different from next month's. Each season's monthly contest supposed to cover the same scope. It is just giving the people who did not have a chance to advance to the next level a chance to try in the same season. Or the people who want to try the next level, another chance, or keep another opportunity. So in theory, a student actually can pass all the levels in one, I'd say in one contest, if they can score all the perfect scores. That is actually allowed, but that rarely happen, obviously, given the challenging level. The last monthly contest is typically called US Open. So the schedule is published on their official site. From their landing page, you will see the schedule, the exact schedule. So each contest month, they will choose about like a middle of the month time weekend, from the Friday through Monday, overlapping the weekend, a 4-day long contest window, and the students can log on online and participate anytime they want. However, once they click the button to start the contest, they will see a 4-hour time control, typically solving 3 problems. Each problem will have about 10 to 15 test cases. The algorithms to calculate the scores are 1,000 points over the number of test cases, and then by the cases that pass or solved by the student solutions. If it's not a perfect score, then usually briefly after the contest ended, then they will announce the cutoff line. It is usually somewhere between 700 points to 750 points in the recent contest. If you pass that cutoff line, then you will be able, the student will be able to promote into the next level or division. Flip, please, Harrison. So the USACO's contest problems or the scopes are typically like those of IOI. I list some of the classic topics here. Very, very algorithmic. And this is all the USACO is about, right? Algorithms. Only thing that they don't challenge audio, video, graphic, web programming. No, nothing of that. No animation, nothing. Just purely algorithmic context. So for example, Harrison, right? You have participated in the LeetCode's code challenge solving, right? So compared against LeetCode, which is supposedly for the programmers who are looking for job and preparing their coding interviews, right? They are similar. It's just that I would say that the problem setup are slightly different, where the solution requirement is bigger and more challenging for USACO. But they don't really, but they also just organize that by the division. Like they have like a no algorithmic background for bronze, and then somewhat some easier skills for silver, harder for gold, and such. Yeah, please flip. Now, here are some of the challenges in preparing the USACO. There's no such thing called textbook. There's no clearly stated contest scopes, like what will be challenged, what will not be challenged. The topics that I mentioned in my earlier slides are all just from history, the internet discussions that people say that, oh, you know, just a summary of what we discover from the past contest problems. And the contest is all by problem-solving skills. Some of the algorithms, I would say that they are college level, and some of them are even graduate school level. It doesn't necessarily mean that the contestant have to master the theory, prove the theory, and all this. They don't have to, but they will be required to apply the algorithms and code the solutions using the algorithms. So that's the challenge. Yeah, please flip. Yeah. Now comparing the two, right? I think ACSL is leaning more towards the breadth, covering the introduction of the computer science concepts, the basic programming challenge. There will be no or very, very little or very light algorithmic topics that mentioned by the ACSL programming problems. The difficulty of the ACSL programming problems or challenges are more from a lengthy task, mission description, and implementing a very, I'll say, a bulkier, heavier weight content. The USACO solution sometimes are very short and concise, but the challenge is really, really deep. A lot of times you have to really understand what the problem is looking for, and in order to code up the solution. So you might sit there for 3 hours and scratch your hair, and then you wouldn't figure out even a single problem. That's very likely. So ACSL is a team-based, for the 4 contests and 1 individual base for the final. USACO is only individual based. And they all are actually online. USACO uses its own online code judge system. ACSL's recently migrated, in the recent years, it has migrated to the hackerrank.com. And ACSL allow in-classroom contests. I don't think USACO has in-classroom contests. So I mentioned about the mission of the 2 organizations and their contests a little bit earlier about the, I think I didn't mention much about ACSL. ACSL doesn't really have any like a international competition in the like a final stage. It's more they have sibling or partnership with the other international communities or organizations, and distributing their contents and allow them to use their contest formats. I actually have students in China, Korea. They all have organizations that are running the ACSL contest. The contest problems are similar, but the formats are quite different. It's still team-based though. And so now let's continue. This is what I summarize the prerequisite for ACSL and USACO both. They actually, I would say that they share a lot as a beginner to start with. I would say that ideally for any students who have knowledge or who have mastered the following language semantics, they are enough to begin or trying. I would say that begin their challenge of the ACSL or USACO problems. So these are all the very basic stuff. So given to what Harrison mentioned earlier, I think the beginner Python, maybe the Java one, they are both a very ideal curriculum in building up the foundations and satisfying the prerequisite for the ACSL and or USACO. And for example, I can see the difference between the advanced Python, between advanced Python and the beginner Python, like the object-oriented programming part, right? That's actually not required. It's good to have, but that's not something really heavy. Like for example, the contestants for both ACSL or USACO, they don't actually need to implement any classes. Typically, rarely, I would say they rarely need to. And building up multiple files. Usually the coding solutions for both contests are very short and concise. Think about how much you can do in an hour, right? How much you can code, right? So, not much like a classes building, modules, packaging, nothing. Typically just one file, and then using the standard input, standard output, right? Take the input, produce the output on display, and make sure it matches what the code judge expect. So that's the format. Yeah, please go ahead. There's some links that you can know more. Yeah, please go ahead. Okay, I think that's all from me. It's very a lot of like technical details about how the contest organized. So a little bit side note from my past experience and coaching the kids, I would say that the two have a very different mission. ACSL is more promoting the computer science principles and basic programming skills. I would say that like in a breadth level, right? It's promoting the computer science and programming. USACO is challenging the problem-solving skills, right? They make the problems really, really hard. I don't think I've been doing programming daily for many years. I passed the silver level. I haven't had time to work on much on the gold level. I did, try some of the gold level problems, and also I exercise on LeetCode from time to time. And my opinion, by the way, also look at IOI problems. I think IOI problems and the USACO problems are very similar. It's just the like the code forces problems. The problem creators, they are from a different country. They have different cultures. Sometimes you can see a little bit background. Some people trying to make the problems very academic. It's full of like formulas and academic terms. USACO problems tend to be, they usually try to put some story background there. ACSL is similar with more story background. I would say the more verbose on describing the details of the missions that need to be done. And so for in-depth mind challenge, problem-solving skills, USACO is the direction to go. But USACO is not, in my opinion, it's not for everybody. It is not that interesting for average, I would say the average students. Only will be very good, helpful, in my opinion, for a handful of students who have demonstrate their above average problem solving skills and mindsets, and very good memorization and abstraction thinking, critical thinking, problem solving skills. So all these different criteria are above average. Then I would recommend to take a little bit about USACO. But I still think that if the kids are very interested in programming, it would be good to give it a try. Sometimes it's good education, resources to see how people can think and look at things differently. So very enlightening educational resources, in my opinion, for USACO. And while the ACSL could be a very good stepstones after the beginner Python or Java 1, or for students who are interested in preparing their next step. Okay, I think that's all from me.
Well, thank you. Last quick slide. I talked about this very, very briefly. A little quick slide on AI, since it's the popular word as of now. It is becoming more and more popular and more useful. You can see like ChatGPT and Google Bard and Microsoft Copilot, and it's a very powerful tool that allows us to do a lot. And because of that, again, let's loop back to the idea of, okay, why do you need programming, right? Why are we offering classes? We are offering like coaching for these programming competitions, right? Because it's a building block for you to learn and for the students to kind of learn about AI and the future of programming. And I think it's definitely a field where it's of a lot of interest right now. So kind of going to loop back to one of the questions I saw earlier is scrolling up. Okay, yeah. Like, what programming skills cannot be replaced by AI? And a lot of times the AI might be able to program better than you sometimes. But I guess what you want to think about is, okay, well, I need to know why the AI is doing that you can be the one programming the AI to program the code. And that's kind of the thought process here. Exactly. Learning code so you can build the AI to actually do what you want it to do. I believe that's it for the presentation. I have some questions to go back to answer. So let me scroll back. One of the questions here, it's, can a fourth grader with no computer class experience join beginner class without any problem? Definitely. Basically, it's a class for no experience required. I can go find that slide. There you go. Yeah, no programming experience required. All good. As an adult, can you take the advanced Python class? Yeah, you're feel free to, if you want to take it, go ahead. You will have you may feel it becomes too easy, and that's not unsurprising. It could be good for you. It could be a good fit, but typically, because these classes are catered towards younger students, it'll be I'll be talking at a pace where it's more suited for an audience that is, give or take middle school, elementary school. And so you could be feeling that, oh, it's a little, I could go faster, and I will move at an appropriate pace that way.
Oh, as a side note, as an adult, I also participate in the USACO, which are supposed for the high school students.
Yeah, and I think that's a really great option. If you think you want some challenge in programming, go ahead and do what Mr. Rao said and head towards the USACO competition.
Oh, yeah. So honorably mentioned that one of our pyramid student, Freddie Tang, and he, I remember he was one of the, was the coach that coaching the advanced USACO level, and I was part of in his class, and I learned so much from him. A lot of time that I understand that people trying to advertise this way that I worked with him, and then he did well. But so he actually did the. I mean, I learned so much from him the other way around. It's actually. He, when we met the first time, he already passed bronze, and then I probably just passed silver. Then he worked on the gold, struck a little bit past gold, and then advanced to platinum. and then he was in the summer camp. So that was for so how many years? I don't know. Like the first time that I know in my knowledge that we have an Illinois students that who qualify in the summer camp. Yeah, can you one step forward, one slide forward to the track? Yeah, the first one, the progress track, right? The bronze, silver, gold, platinum, summer camp, and finalist, right? So we met when he was silver, and then when he's working on the gold and platinum, I kind of talk to him and his mom from time to time, so I know that he's making good progress. Then one day, and then I learned that from his mom that he was in the summer camp. Wow, that was great. First time I heard the students in the summer camp, 20 students from nationwide. So I have so many students who struggling, stuck, and could not make forward. Right? So he's one of those outstanding students. So after that, I did actually help Benjamin Chen a little bit. 3-day camp, only a 3-day camp, honestly, right, when he just started. But then, he very similar story, but rarely happened actually. He advanced, I don't know, eventually I learned the news that he was in the summer camp. Then he was one of the finalists. One day when I opened up the landing page, I saw his picture from the USACO's official site. Later on, I keep getting the updates from him, and he scored the 24th in the IOI, I believe, and get a gold medal. I think, yeah, that's the closest person I know that on this track that has done the amazing job. So, but it doesn't mean that the other students. I think they all have their different resource allocation and interests. I remember Jerry Chen so much. I believe he's on the platinum level. He also had his own math club, by the way. He probably spent more time on his math side than the programming side. And there's a few other students who pass various different levels there. So I feel so. I think one thing I feel what motivates me most is I feel that I've been lucky that I can work with like including Harrison too. I remember that we spoke. I invited him to and helping me to create and organize a coding club, right? Remember that, right? And then I introduced him to the Pyramid Academy as a coach there, which it's just great that we can have him. I'm so happy to have him. And since then, we enrich our curriculum and course selections, and yeah, just so that's beyond words. And so I would say that I've been lucky to work with so many different talents, and I see their growth and advancing. And I understand that topic they're tackling is so challenging. And when they move on and they make a little step forward, every excitement is really a rewarding and encouraging me to coach and to help. And I also learn so much from them, as I mentioned earlier, from Freddie and Benjamin and Jeffrey and many more students. So yeah, this is one thing why I'm still why I'm here and introducing these topics to you guys. Yeah, okay, I think I should stop.
Yeah, this is just a testament to how we will go over time and continue talking about these topics, but trying to get to all of your questions really quickly. By Mr. December, can students still join USACO contests? I believe from Mr. Rao's slides here, they start from December through the spring of next year for 4 monthly contests, so they can definitely attend these monthly contests.
Yeah, there's no anything restriction. All you need just go to the sign up page from their official site, and then fill in your information, like the name and school and email. I think pretty much that's it. and there are many OCDS problems you can exercise. You can submit your solution to their online code judge. It's the same system that how they use in their real contests. So feel free to exercise and then also use they have also a training gateway, which is a different system. I mean, I believe a different user system, so don't confuse the two. If you have any questions, feel free to reach out to me. I can help you with more details. But yes, definitely you can join when the contest season is like right now it's ongoing. We just, I think the December one just finished, and the Jan one is coming next week.
Yeah. The follow-up question is, will he miss the prom in December test? I'm pretty sure you can find those, right? And then still practice on those problems, even though they're not going to be graded. Is that correct?
Yes, I would say that they will not be considered in your level advancing or the progress track that I list in the bullet point in this slide on top one, right? But it's a good exercise. You can submit your solution anytime you want. All right, I actually, been practicing that tool. It's a good, helpful resource to improve your coding skills and problem solving skills. Just like
Python, Java are good tools for USACO. Is disadvantage and challenges for C++ compared to the other two languages?
Okay, I can answer this one. So it's it really depends on what I would say that if the students are very has demonstrated very strong qualifications and interests, then C++ is the direction to go, because it's a fact that I would say that the majority of the competitive programmers, they use C++. The reason, in my opinion, is that later on C++11 version and those higher that has offered good gadgets in helping the programmers to complete the algorithmic implementations. Where versus the Python is lacking some of the basic algorithmic like data structures. Like for example, when I code the stack, when I code the queue, priority queue, tree, should say map. Like for example, I want to have a order map thing, right? It's like a not ideally to use Python to code it up. Now compared to between the two, right? We have Java. So what's good for Java is it has all those algorithmic gadgets or tools, libraries that available handy. And also have like a big number class where that's almost impossible for C++ to code it perfectly in a 1 hour or 2 hour coding contest. But the downside of Java is two verbose. Like in Python, it's very concise. You can code something like in a few lines. Even a lot of Python programmers, they do one-liners. One line does everything. In Java, in order to just do simple tasks, you have to code a lot of contents. Why this is important? Because all these contests, especially the USACO contest, is a very I would say that the time pressure is really huge. The thinking already take a huge portion from your contest timer. Then you have to code up the solution. Now you want to prefer to code it in a very concise way. I think C++ is a good balance between the two, offer comprehension gadgets, and then the concise language semantics to implement the ideas. So that's why the advanced levels, they all use C++. However, though, to begin with, for beginners, it doesn't really matter. Whatever language you like, Java, Python, C++, whatever you already know, and you know the prerequisites, you can begin with. Yeah, that's all.
Well, that's a good answer. Next question. Sorry, we're moving a little slower than I like, but we're just keep on getting through these questions. For smaller kids, keeping them interested in programming is very important. I'm wondering, besides participating in competitions, whether there are other interesting activities or resources for them. For example, using programming to do interesting graphics or games. Some tutorials, lessons on these can be very useful. Yeah, it's 100% true. Just like what we've mentioned here is robotics is a really great option. It's really all about what your student or what your child wants to learn. If they're interested in robotics and trying to tell the robot what to do, right? That's a great option. If they want to program games, yeah, there's a lot of different resources online that you can kind of look for, or if you want something like that at Pyramid, we can talk and try to figure out if that's an option to make a class like that. Is there any more questions? What would you recommend for kids in grades 1 to 3? It really depends how strong of their logic comprehension, because programming is very, very logic based. It's very strong logic, and so the recommendation is if they have a good grasp of pre-algebra, right? They understand a little bit about some logical structures, right? Then I think programming is the beginner Python's a good fit. Otherwise, there are different other resources that a lot of other beginner tools such as Scratch, where it's less programming language based. It's more teaching you the logic behind the programming, and therefore once you learn the logic with Scratch, with Alice, with all these other more game-like tools, then you can kind of build to, oh, now I can start learning languages with these logic. Yep. And code.org has definitely free lessons in building small games. There's definitely some YouTube channels that also do that, but keep in mind, you'll have to sift and find some good resources, since there are probably videos and for any level, for a lot of levels. What game toy do you recommend for younger children?
Okay. Regarding about the progression or the study track, I want to add a little bit more comments, because one thing I noticed that in the past, from all the students I've been work with, right? I think giving up too early is one, I would say the one dominant problem, because the subject matter itself is a very challenging subject. Sometimes the parents have high expectations, and also the kids. But in the reality is that they will typically hit a few bumps down their study course, because the first bump is mastering the syntax. For students who has already studied a Scratch, which is a graphic base, right? That they're going to transit to a script base like the Python or Java, right? So this is the first bump. The second bump is transiting from learning the syntax into application and building up the solution. So the students typically understand all the syntax. They can fill in the blanks of the questions and then completing the those code.org, Codecademy, Khan Academy problems very quickly. However, though, once they want to land their hands on their keyboard and trying to code everything from scratch, they stuck there. So this is the second typical bump there, where they have the basic knowledge, but they are lacking the practice. They're lacking the experience. They don't know how to lay down their first Lego piece and the other succeeding following pieces, and then build their a tower or a car or something, a truck, something. So this is the second thing. So I would say that, after, let's say, starting Harrison's courses, I believe the students should all have a good understanding and exercise, in knowing those tools. Standard third bump will be the more typical in my class, where it just the competition is so tough, so competitive, so challenging, and a lot of time that, for example, I'm just sharing my experience, right? I know the language, no problem. I've been doing that for like 20 years, right? I know the idea. It's already mentioned in their official solution, right? I know the tool, I know the direction to go. I just still couldn't figure out. Definitely, I'm strong in implementing the ideas, right? So I have no problem at all. But still, I cannot figure out or write down, code up the solution. Why? Because I have not catch the solution. I have not get the solution how the problem is solved, right? So that's the challenge. So, and this third challenge is like very common in the USACO, especially USACO contest preparation. I have a student who started from fresh. He learned C+ from me actually, and at the time that I don't remember like so many students that work together, but he's the one that's keep doing it for like 4 or 5 years. Eventually, he's tackling the USACO now. So I would say that really depends on different people. Some people, they just have I would say that a different pace, right? So I would say that parents, students, families, right, have to have enough patience to give to motivate the kids, motivate to maintain the interest, and then just keep trying. I would say that don't abandon idea. You might not. You can give it a try. Always try first, but don't like say, what, I cannot do this. This is not for me, right? You try, you don't like it, right? Maybe come back another time, right? After studying some math on building up some logic or critical thinking, and things could be quite different.
There's a follow-up question for you. How can USACO and ACSL scores or awards help college and admission applications? Did the achievements of your students in USACO help them get into their ideal colleges?
This is I think I would say Miss Lee probably has more to comment, but before she introduces her thoughts, I would say that it helps, especially USACO, the achievement like a summer camp finalist, like a gold medal in IOI. This definitely going to go. I would say that definitely going to get you into the top schools like MIT, Harvard. You can check all the the finalists where they ended up with, right? But however, anything other than that, I would say that it helps, but it really depends on how the school look at it, because I believe most of the schools are running a holistic review process where this can be something add weight on your add some highlights into your portfolio, but this is not going to be a dominant factor. So I would let Ms. Lee to share more her thoughts.
Thank you, Ms. Changzhen. I think you're right. So we always say, the top competition winner cannot guarantee to any top school, but it's really helps, the other way around. When you think about it, the college application, sending in, I think the admission director always check, have you have any chance, ever, win some very, very top competitions. So I know a lot of USACO, winners actually, kind of getting into MIT, especially MIT, who really, really, look upon for those competition winner, like a math, very top math competition and all those Olympiad, competition winners. I think MIT gave them, I think a huge weight, on their admission decision. But not, we are not saying guarantee, but I can see, so I think coming into competition, like Mr. Changzheng says, I think it's like what is the best for your kids. And like Harrison mentioned, the interest, don't push your son or daughter to win the competition because you want him to be the top Ivy school. I think it's the other way around. If your kids have a really good interest in the competition, trying to nurturing him or her, trying to let her, him win, kind of naturally win the competition. I believe the Ivy League will definitely, open their door for your kid. So all the time, if you win the big competition, it definitely helps. And make sure, of course, you will, put in your, documentation application, you will write about it, kind of don't hesitate to brag about it. Actually, it's not you winning award, it's how you win it. How you win it, what have you learned through this of years practicing it? So sometimes I think Chinese parents has a tendency, or Asian parents has a tendency to look at the end of the competition. So, but to me, as a counselor of a college application, I would like strongly recommend you pay more attention to the process. So what did you learn? You put down those kind of thoughts and, experience in your application form. That will help you tremendously to get into the university, especially, for example, like Harvard, like, Stanford, those are looking for the leaders, those are looking forward for the creative person. So those kind of idea, is where they find it out, through your papers, through your experience. I hope I answered that question. Oh, by the way, so Harrison, I think some parents ask me, because I mentioned about the Lego education and the regular Lego. So all the Lego pieces without any motors, without the robotic part, is produced by Lego kind of a department. So Lego has two sessions. Another Lego education, they mainly produce anything related to the robotic part, but it doesn't have to be the robotic competition. It's just robotic, kind of toys. It belongs to the Lego education. It's not sold in the regular Lego store. You have to buy it from the online, from the Lego education. That's why I want to point it out. So back to you, Harrison.
Yeah, thank you for that. It's actually super good information. I can do a quick search and see if I can find it. Okay, so a quick search. There looks to be a lot of some resources here when my first time looking at it, but it ranges from like pre-K to in elementary and middle school. So
yeah,
definitely worth considering if you are looking for like robotic Lego based education. And yeah, I believe those are our final set of questions. Anyone that has any other questions they'd like to bring up?
I think they mentioned about Science Olympiad. So Science Olympiad is a little different than the USAMO and the US PHO. So it's a different thing, but I think last time I did introduce in one of the group, but I can dig it out and sending out to the USACO group. So if you join the USACO group, you probably will say, or, reach out me individually. I can help you to provide a little bit basic information. Yeah, we got so many, a lot of things related to Olympia, so it's kind of confusing. So many different kind of, competition. Yeah, but Science Olympia, I think, is among the top one, but it's not like USACO or USMO, USA, PHO, those kind of etc.
All right, thanks for that. That's a very good answer. Oh, you have a question?
No, I think probably about it. Would you like to? I think.
Right. If there are no further questions, then we can wrap this up. Thank you everyone for showing up.
Yeah, and thank you everyone for coming, and thank you for Mr. Harrison, Mr. Changzheng. Never enough to thank both of you for not only do this presentation. I think most like the beginning, I think the most important, you have a heart for teaching. That's a part I think is the lucky of our community kids. And thank you all for coming. See you soon in the next one. We don't know when, but soon sometime. Okay. Have a great weekend, everyone.
Maynard question to Mr. Rao.
Oh, another question? Okay, go
Yeah,
ahead.
I think I just found it. Can my child join the USACO group remotely?
Yes. The USACO contests held online primary. There's no like even they moved the summer camp online. So yes, you can join anytime. It's not a group or anything. It's just an online account so that you can have access to their contests, the online co-judge. In the non-contest season, you can use that account to exercise with the old contest problems, right? To see, to get an idea, to see how strong you are, or to exercise a bigger type of problems. Any of the during the contest windows, it's also the site that running the contest. So you just log onto your account, you will realize there's a button there. You click enter or you click start, then you will enter into the contest room to solve the contest problems online. So it's all done like online. So it's all remotely. So if you so there's no such thing called group, but there are some third party, I'll say that websites or organizations that they're mostly the ex or veteran USACO contestants, where they offer their curriculums, materials, or experience or helping people. So those mostly I think find them from Discord or I believe there's Discord channel or something.
Yeah, we wants to offer a club, but it didn't very successfully, but we did run the whole summer actually. So I'm planning to probably, run more clubs in the future. So hopefully the kids can, learn it together, like a support, group. And then, Mr. Chandong would like to coach a little bit, some kind of things like that. So, watch out our news. Hope we're getting there. Okie dokie. So thank you again, Ms. Harrison, Ms. Chandong. Thank you again for, give us more questions.
There's another question. I think there are two different things. I don't know Science Olympic much, so it's good. Like Ms. Lee, maybe you can explain a little bit more. I think it's more like a project based, right? It's not just a hard skill, but also some like a leadership and communication skill that required, right?
It is a competition. It is a competition. But if I remember correctly, sorry, I'm getting old. If I remember correctly, Science Olympiad are more like a kind of content. Basically, are you able to memorize the knowledge about the thing? It's not like USACO. You basically have to problem solving. That's what I remember. Okay, like I said, I will dig out the documents and provide it in a group. But that's what I feel. So actually, that's why I feel USACO, USAMO are more, a little bit higher level, because those are really, problem solving. Like Mr. Chandong says, we are the expert. We do the, coding all the time. Doesn't mean that we are able to solve the USACO problem, because that is a problem solving using the code. Okay, so it's required you able to figure out the algorithm before you solve it. That's what I feel. And so I will definitely, I promise, I will dig out the information and send it in the group. We are about, Pyramid is working with Center for Future Innovator to provide more robotic class in the future. So if you are in the Aurora, Naperville area looking for our, maybe in the summer season we can start it, but we cannot guarantee. But there are lots of inquiries because CFI has a winning team. So we're thinking to introduce their experience. They even have the little one. They even have the We Do Lego education program for the 4-year-old. They're so cute. Learning making the We Do robotic and learning the old scratch code. So cute. That is the cutest child I ever seen. Okay, but you will know me more. I love kids. Okay, by the way, I really love teaching and I love kids. So we do have robotic class coming. I'm thinking in the summer. I'm trying my best to roll over a lot of new curriculums. As you have seen, we have a new IEW writing classes. I think our community needed because our kids, normally they're good at STEM, but they're not good at writing. So we need a more creative writer. We need more good presenter, like one of the parents asking, how can our kids enter the top school? Because I'm thinking compared with other ethnic groups, our kids are smart, but we somehow need to learn more ways how to present ourselves, how to be more creative other than just be the stereotype of a nerdy kid, right? That's something we want to get out of it. I think that's one of my goals as a principal of Pyramid. I hope with all our wonderful coaches, teachers, we can make it, and of course with the parents. Okay, I think Ms. Changjun trying to answer about the group, join the USACO group remotely. Wonderful. Oh my God, we have so many great questions today. I'm so excited. I think the better questions, that means, our parents are thinking, and I hope this pathway, lecture really help you guys. So like I said, plan well is always the main important role as a parent. It's not just we pushing our kids into some competition. It's, find your kids' talents, find their uniqueness, find whatever competition works for them, and then help them to kind of winning. It's not, for winning, but for grow. I think to grow their talents, for grow their contents, most important, to grow their problem solving skills that they can survive. They can surpass the AI, right, Mr. Harrison? We should be. Like I'm always joking with the kids, the AI, without people, there's no AI. So we got to, the AI won't give a birth by itself. Hopefully not, right? So it still have to be us human beings to create the AI. So I think that's a way we should look at it. Okie dokie. I think I will, wrap it up here. So again, thank you everyone. Really, really enjoy talking with all of you. And feel free to ask questions, to connect with us through all the WeChat groups that we have. We trying to separate different, create topics, into different WeChat groups. So sorry, we kind of have a lot of WeChat groups right now. But as far as you are in one of it, or the area where you think the kids is good at it, you are good. Okay. So thank you everyone. Have a good night.